Start with a little video. Alright, I love this scene so much. Tom Cruise, what a badass actor. And I guess in this scene, a badass hacker. And that computer that you saw, circa 1990s, that was one example in which people were hacking into systems. And that wire that you see over there, that's just pretty cool to look at. The age of the internet has really changed everything. The way devices are connected, the way systems are connected, it's unleashed all this innovation. But at the same time, it's actually increased the surface area in which hackers can use to attack your systems. So, in this talk, we're going to be speaking about how your APIs may potentially be insecure. So my name is Nick Tran. I work for Akamai. We are actually the world's largest CDN network, and we power anywhere from 15% to 30% of the internet's traffic on any given day. So we see a lot of internet traffic. And we're now one of the top cloud security company in the world. Last year, we defended against the largest DDoS attack that ever happened. That was against GitHub back in the spring of 2018. Yeah, so I head up developer relations for Akamai. My job is to make sure that developers understand and have what they need in order to build, fantastic experience, including ones that are secure. So let's take a look at API usage in general. So what we saw or published recently was that in 2014, the majority of the web hits that were happening was happening via browsers, 54%. Fast forward to 2018, APIs are now the things that are seeing the most amount of traffic. API calls dominate overall web traffic. Why is that important? That is important because the vast majority of attacks now are targeting APIs because they represent a much larger surface area. And as a result, they are becoming the primary target for attackers today. There's another reason why APIs are particularly juicy for attacks. They are actually cheaper to attack than your standard website or web page. And the reason for that is if you're attacking a web page, you might have to screen scrape, and walk through the DOM, figure out exactly what you should be attacking. With APIs, it's a straight call, right? So it's less computationally intensive to attack an API versus attacking a website. And so between those two things, the fact that, again, the majority of the traffic are APIs, and the fact that they're cheaper to attack makes APIs very, very juicy to attack. The other thing to note here is that, I just moved back one slide. That is, a third of the API traffic comes from your mobile phone. The other 2/3 come from connected devices. Your connected car, your connected camera, even your connected toaster. There's a connected toaster that sends you an alert after 2 minutes and 30 seconds, signifying that your toast is done. Imagine that. So, the 5 areas in which your APIs are most insecure, or most vulnerable. They are DDoS, parameter attacks, SQL injections, network traffic sniffing attacks, and credential stuffing attacks. There's a few more, but these are the 5 primary ways. So let's take a look at the first one. A DDoS attack. Everyone is familiar with a DDoS attack by now, right? But with APIs, it actually makes it even easier. And which makes it really also kind of hard to defend against, because APIs, after all, are built for scale, for high bandwidth automated types of transactions. So how do you differentiate like an attacker doing repeated attacks, repeated calls to an API? It's really hard to tell. So there are basically 3 considerations that you need to know about attacking DDoS attack, DDoSing an API. Number 1, that traditional request rate-based controls are really, really hard. You have your API key. You got to authenticate for that. You have your authorization. What do you have access to, right? If you have 1 million API quota for the day, how do you keep track of that on one server? How do you keep track of that on multiple servers? How do you keep track of that globally? The second thing that you need to consider is that input validation is really, really difficult. And that APIs are meant to be infinitely flexible. They, again, provide you with all the innovation that your company is looking for from like the ecosystem with partners and whatnot. But because of that, because of their flexibility, it makes it really hard to validate the inputs that go in. And also, how do you validate against like an API that's expecting 100 keystrokes versus 1 million keystrokes? That would totally overwhelm your origin server. And the third consideration is that we live in this SaaS world where everything's in the cloud. We have partners that expand our ecosystem. But how do you know whether your SaaS partner wasn't compromised in making the API calls to your server? So, amongst these 3 considerations, if you think about a DDoS against an API, it becomes really, really difficult to defend against. Another way that APIs are getting attacked is via parameter attacks. Very much like a browser parameter attack. You insert in a parameter in your query string, and then all sorts of things potentially open up. Now, I work with a lot of engineers, and what I see is that oftentimes, they build their functionality, they build their product, and they're then mandated to expose their services as an API. What do? They slap on app web service method call, and boom, you have an API. The last thing they're thinking about is API security. And what we see often is that also engineers, you guys are good at what you do, but most of you are not API developers by trade. Okay, so this is actually a really big one. This is actually not a new attack. SQL injection. We see it all the time. It's actually been the most dominant way that hackers gain access to your data for the past 15 years. It continues to be the dominant way that hackers are attaining your data. And that is with SQL injection. So that is the big takeaway from here. And again, most APIs are not protected. It's usually an afterthought to protect your APIs. And developers tend to think about protecting their website, their web pages first. Another one, just don't use HTTP. We still see that, and I think many of you know now that Chrome and Firefox last year release updates to the browser back in July, where if you're accessing an HTTP site, it's going to throw up a gnarly error. Please use HTTPS, use TLS 1.3. That's the recommended security certificate that you should be using today. Everything should be secure. If you're using HTTP, there's tools that can sniff your traffic and steal your valuable information. Okay, I'm running out of time. Number 5, credential stuffing attacks. We're seeing a lot of this from within our network. Our customers are experiencing, so credential stuffing, let me back up. Credential stuffing, also known as credential abuse, is whereby bad guys are stealing or getting a hold of username, password combos, credentials, and they're taking those credentials and they're using it on other sites, hoping to be able to log in, hoping that you all might have forgotten that you had used that password before, and then be able to gain access to that other site. We're seeing the same thing with APIs. 28 billion credential stuffing attempts in the last 8 months. That's pretty insane. The other thing to note is that with typical authentication via a login screen, right? We oftentimes see CAPTCHA, reCAPTCHA, and to determine whether you're human or not. So that's all JavaScript based. With a lot of the connected devices, they don't run JavaScript. So they talk directly to the APIs. As a result, there's not that mechanism to validate whether the API call is valid or not. And here's an interesting stat for you. 67% of all login attempts were fraudulent. That's astounding. The majority of all login attempts were done by bad actors. Okay, winding down here, 4 minutes left. 5 areas in which your APIs are most vulnerable. DDoS attacks, parameter attacks, SQL injection attacks, network traffic sniffing attacks, and credential stuffing attacks. And there's one more attack that I didn't really talk about here, and I'll just quickly share that with you. What we saw recently was a restaurant, let's call it a pizza restaurant, was noticing API calls to place an order for a bottle of soda at exactly 9 o'clock in the morning and 5 p.m. in the evening. And it perplexed the customer and us as to why the attack was happening. Why every day there was an API call to order a bottle of soda at 9 o'clock and 5 p.m. and that the soda was never picked up. The credit card went through just fine. Because the customer never came in to pick up their bottle of soda, the transaction was reversed. So there was no harm there. What we surmised was that the attacker knew that when making the order via the API, the response that they got back contained the order number. And that throughout the day, the order number would increment by 1, plus 1, plus 1, all the way till 5 p.m. From that, they were able to deduce exactly how many sales that particular store did. That's pretty sneaky, if you ask me. And so we don't know whether it was a competitor. We don't know whether it was someone on Wall Street trying to get some intel on whether the company, the store, or the chain was doing well or not. But that was an interesting way of using APIs to extract information. But there was no harm done to that particular store on the surface. So my ask of you is to start thinking about developing an API protection plan, starting right now. And that within 7 days from now, you should identify all the APIs that you have. And then within 3 months, you should understand who is actually accessing your APIs and define an appropriate API security protocol. And then within 6 months, you should think about selecting a security vendor like Akamai to help you with your security needs. And then you start securing your all your APIs, both public and private. All right? So one thing I'm going to leave you with is your mission. Actually, on Wednesday, April 24th, we have Goku here. He's going to be giving an in-depth talk as to how to actually secure your APIs. So definitely check him out. That's at 2:30 in Hall A. And then the last thing I'm going to leave you with is your mission, if you choose to accept it, is to secure your APIs, because I don't want my connected toaster